This chapter 1 teaches you to depict an interest rate exposure by means of a simple graph and to explain and quantify the consequences of leaving the exposure unhedged. We begin by taking the simplest of all interest rate exposures, one that arises in the ordinary course of a company's borrowing operations. Suppose that on September 1, 2009, a U.S. company borrows $100 million for 5 years at 3-month LIBOR plus 100 basis points, when 3-month LIBOR spot is 5%. We remind you first that while it is the LIBOR rate at 11 a.m. London time, 2 business days before the beginning of any interest period, that is used to fix the coupon paid by the borrower for that period, the payment of interest occurs on the last day of that period. On day 1, the borrower knows exactly what his interest payment will be at the end of the first interest period, but not that of any subsequent period, since this will depend on the LIBOR fixing for that period, which may be higher or lower than the initial 5%. Note that in addition to the first setting for the September to December 2009 period, 3-month LIBOR will reset a total of 19 times prior to the loan's maturity, scheduled to fall on September 1, 2014. More specifically, the interest payment at the end of the first period will be 100 million times 6% times 91 over 360, which gives this 1.5 million and change number you see on the right, but could be substantially greater if 3-month LIBOR were to rise and substantially less if 3-month LIBOR were to fall. Worksheet Borrower Exposure lists in column B values for 3-month LIBOR spot ranging from 0.5% all the way down to 9%, and in column C the corresponding annualized cost of the loan, including the 100 basis point spread in percentage. The upward sloping shape of the graph appearing to the right should not be at all surprising, since the borrower pays more interest when LIBOR increases, indicated in our graph by a move towards the right on the x-axis towards the values 6.4%, 7.4%, 8.4%, and so on, and by the same token, a decline in LIBOR is indicated in our graph by a move towards the left on the x-axis towards the values 2.4%, 1.4%, 0.4%, and so on, resulting in reduced interest expense for the borrower. A good exposure diagram would presumably conclude by flagging the area of the graph that represents the undesirable outcome for the company. In this case, clearly the area towards the right, where the interest expense is increasing, often done by use of funny faces, as we do here, as well as the desirable outcome represented by the area on the left. One final question regards the range of values to show for the x-axis variable on the exposure diagram. There is no unique answer to this question, but consistent with many measurements in risk management, an interval spanning 2 standard deviations up and down from the current level may be a reasonable one, since these would cover some 95% of all possible outcomes. To illustrate, suppose that the standard deviation, also sometimes known as the volatility, of short-term LIBOR over the long term has tended to be around 100 basis points annually. Our suggestion, Jen, would be to show the range from 200 basis points below the current spot of 5% to 200 basis points above it. This means, of course, the range from around 3% to 7%. Our earlier diagram spanned a wider range because over 5 years the range of values LIBOR could reach is substantially wider than over one single year. This way, you would be showing the client scenarios that have some plausibility without going to absurd extremes and being accused of trying to scare the client into doing a deal under any circumstances. If we now take the case of an investor that owns a floating rate note paying 3-month LIBOR plus 25 basis points, say, we would recognize that this time it is the investor's interest revenues, not her expenses, that we would plot on the y-axis of the graph, which would make the area that is lowest the least desirable, and the area that is highest the most desirable. The graph in this worksheet, Investor Exposure, confirms this and indicates clearly the undesirable area towards the left. Once again, smiley faces are available to assist us in remembering which direction is which. You might conclude this exercise by showing in tabular form the approximate probability of each scenario and its outcome on the company's financial performance, including the effect the unattractive scenarios would have on the company's key financial metrics, such as net income, EBIT, EBIT margin, or any number of other alternatives. If you decide to do this, however, you will have to make very clear what assumptions you have made and point out that many of these calculations are based on financial models that are known to be inaccurate to some degree and are frequently evolving. Illustratively, and reverting to the case of the $100 million 5-year loan, assume the borrower's income statement for 2008 showed net income before taxes of $10 million, so on average $2.5 million quarterly. Since we have quoted an annualized volatility, the easiest is to consider the likely values of 3-month LIBOR for the interest period that begins exactly 1 year from today, which of course will be the 5th interest period under the loan. This enables you to summarize the outcomes of the scenarios depicted in your graph earlier using this table. What are the principal assumptions we would advise mentioning here? They are, first, that US dollar LIBOR spot returns are normally distributed with an annualized volatility of 100 basis points. And second, the assumption that rising LIBOR would have no other impact on the company's financial performance. This completes our first chapter.